Okay, so let's start. Since we have international students, we will be in English, and I'll try to discuss them in Bengali as well.
Can you kindly increase your mic volume?
Yeah. Okay. Am I audible?
Yes, sir.
Okay. So there may be a bit of lag. So I am using mobile data on two devices. Okay, one to record and one to send this video data. So bear with me. Okay. Again, for finals, you will have problems with nodal analysis and mesh analysis, okay, and source transformation. These are basic techniques you will need to use. And I have still seen that you have made a common mistake. For example, voltage source. আপনার যদি একটা voltage source থাকে in a circuit connected to a node, you cannot write KCL here, okay? আমি এখনো দেখতেছি আমাদের লাস্ট কুইজ 4 এর খাতায়ও some of you still wrote KCL equations on nodes with a voltage source. So if you have a voltage source on a node, please do not try to write KCL for that. All you can write for that node is if it's grounded, the voltage, say this is 3 volts, then don't write KCL for this. The correct should be V1 equals 3 or whatever the node is. আপনার যদি কোনো একটা নোডের সাথে একটা ভোল্টেজ সোর্স কানেক্টেড থাকে, ভোল্টেজ সোর্স কানেক্টেড থাকলে ওই ভ্যালু অবশ্যই হবে জাস্ট ওই ভোল্টেজ যে ভ্যালু এক সাইডে গ্রাউন্ড থাকে, or if you know the voltage of this side, you can also write the voltage of that side. So for example, if this was some node with 2 volts and the voltage, then it would be right? So whatever, usually you will have ground. So I'm just showing the ground scenario. Or the other case might be a voltage source and you have other things on the bottom node as well. Okay, so this is V1, this is V2. You cannot CL here. Okay, let me write it here. You cannot write KCL here or here because both nodes contain.
আপনার কথা না কেটে কেটে আসতেছে।
Give me a second. shit. Let's see if it's better now. আচ্ছা দেখি so there okay so যেটা বলছিলাম source here এবং যদি একটা ভোল্টেজ সোর্স থাকে তার সাথে যদি কোনো নোড কানেক্টেড থাকে ওখানে আপনি কেসিএল লিখতে পারবেন না ঠিক আছে দিস ইজ দ্য কমন মিস্টেক আই এম স্টিল সিইং অন কুইজ 4 ওকে আপনার যদি ভোল্টেজ সোর্স থাকে দুই ভাবে থাকতে পারে একটা হচ্ছে এইভাবে গ্রাউন্ডের সাথে কানেক্টেড দিস ইজ গ্রাউন্ডেড ভোল্টেজ সোর্স যদি এরকম থাকে if you have a grounded voltage source you can just write v1 equals to whatever voltage is written here if it's a dependent source maybe you can also write 3v0 or whatever the value is written here okay on the other hand if you have a voltage source in between two nodes none of them are ground right v1 then you cannot write KCL here either
স্যার আপনার কথাটা কেটে কেটে আসছে
এখনো কেটে কেটে আসছে মাইন এই কিছু এটা এখন দুইটা ডিফারেন্ট নেট দিয়ে চালাচ্ছি
স্যার যে জায়গায় কাটে ওই জায়গায় আরেকবার রিপিট করলেই হয় কারণ এভাবে নেট প্রবলেম কারো না কারো সবারই থাকবে
ওকে এটা করতে করতেই তো 9টা বেজে গেল আচ্ছা okay so if you have a voltage source you can never write KCL okay so you have if voltage connected to then you cannot write KCL on either nodes okay so the situations like this is called floating voltage source okay so when you have a floating voltage source you have to do super node আচ্ছা তো এখন ভালোভাবে ক্লাস শুরু করি so again this is only for not for voltage or not for current source okay অনেকে কারেন্ট সোর্সের সাথে গুলিয়ে ফেলেন if you have a current source don't worry you can write KCL this is only volt okay this is only for voltage sources if you have a voltage source connected to a node you can never write KCL for that this is a very common mistake I think almost on every quiz scripts okay আচ্ছা উল্টা মিস্টেক যেটা করছেন the exact opposite mistake you're making is mesh analysis if you have a mesh with a current source you cannot write KVL for that okay if you try to write KVL that's wrong okay if you a circuit some circuit like this and if you have a current source like this side the mesh is on one side okay আপনার যে মেশটা নিয়ে কাজ করছেন সেই মেশটা ধরেন বাই আছে ঠিক আছে এরকম হলে just write, ধরেন এখানকার ভ্যালু 3 অ্যাম্পিয়ার দেওয়া আছে, you can just write I1 equals 3. Okay, যদি এর মাঝখানে আছে, that means in between two mesh, okay, then you have to do super mesh. Okay, you have to write equation, super mesh equation for the whole thing, and you'll have, so okay, let me show it here. Say you have two mesh here, two meshes here, and one is I1 and the other is I2, and the value is say 5 amperes. First of all, the first equation you should write is I2 minus I1 equals to 5. Okay, most of you forget this again, so please write it, don't forget to write it. And the other equation will come from the super mesh 1. You will avoid this 5 ampere current source and write the KVL for this larger loop. Okay, so it for node and mesh analysis review, we will get to some examples. One of the examples, say for example, our quiz 3 question. Okay, আমার কাছে আছে quiz 3. So in quiz 3, we had to do Thevenin. So for example, this is set 2. Circuit was something, there was a voltage source, 18 volts. You had a resistor 6 ohm. You had 3 amperes, 3 ohms resistor, Vx, 2 ohm, and one current 0.25 Vx. This is 2 from. Okay, so you are supposed to find the Thevenin's equivalent. You had to, now what most of you did was compute VOC first. So as usual, we will compute VOC, so that part was for most of the students. Say I'm doing mesh analysis just to show you that if you are trying to find voltage open, it would be easier if you are using node analysis. আপনি যদি নোড অ্যানালাইসিস করেন এটা সহজ হবে, কারণ আপনি ভোল্টেজ বের করতে যাচ্ছেন, আপনি ভোল্টেজেরই ইকুয়েশন কিছু ভোল্টেজ আমি মেশ দিয়ে দেখাচ্ছি, কারণ এটা অনেকে মেশ দিয়ে ট্রাই করতে চেয়েছেন কিন্তু সামহাও পারেন নাই। এটা কিন্তু মেশে বেশ ইজি। ওকে, ফর এক্সাম্পল, if you are doing mesh analysis, your should be point of contact should be, is there any current source? So yes, there is a current source here. যদি আপনার current source থাকে, then ওইখানে আপনাকে সাবধানে লিখতে হবে, right? Like I said, if you have a current source, you can easily write the equation like this instead of writing KVL. So আমরা যদি এখানে ইকুয়েশনটা লিখি, so if we try to write equation here, what we should write is the direction of I2 is in this direction through this current source. So I2 should be 0.5 Vx. Any confusion here? So this is an equation. The other most common mistake is students forget to write the equation for Vx. So this is our Vx, right? Vx in terms of our mesh current. Okay, for example, the only 3 ohm resistor The 3 ohm resistor, the voltage across the 3 ohm resistor is basically Vx. And if you are writing in terms of I2, etc., you have to see which currents are going through that 3 ohm resistor. For example, I can see the I1 current is going through the 3 ohm resistor, and I2 is not, and there is only 2 resistors here. So I1 current is flowing through this resistor, and this is following passive sign convention. So we can write Vx equals 3I1. You can just directly replace it here if you want. Okay, so if you want, you can just merge them together to minus 0.25 into 3I1. Okay, so this is your, yeah.
স্যার আচ্ছা, এখানে যদি মানে নিচে যদি আমি গ্রাউন্ড ধরি, তাহলে আর যদি ধরেন উপরের যে নোটসটা আছে এটাকে যদি আমি V2 ধরি, তাহলে V2 minus 0 তো Vx এর মান হয় না?
Sure. If you want to note, this is your ground, this is 18 volts, this is V1, this is V2.
Yes, sir.
Okay, and you can write equations for V1 and V2. I'm just showing nodal. Okay, sorry, I'm just showing mesh analysis. Okay.
Yes, I get it.
Yeah. So here for the other equation, other node, sorry, the other mesh, we have 2, and oh, sorry, we have the equation of I2. Sorry, I'm really exhausted today. Yeah. And if you write mesh equation for mesh 1, how will we write that? I1 times in mesh 1, 6 plus 3, okay, minus if is the 6 ohm resistor common with any other loops? No, so we don't need to write anything else. For 3 ohm resistor, it's also again not common to any other mesh. By the way, we are not taking this one as a mesh because this is not complete, or this is open, and connection, you don't have a mesh there, or there is no mesh current there. Just like there, if you will have no, you have break connection, right? And minus 18 equals 0, because you have an 18 volt voltage source and you are hitting the negative sign. So if we rewrite the equation, we will see that I1 equals to 2 amperes. And from this, we can actually get the value of I2 directly. Minus 0.75 is minus 1.5 amperes, right? I think so. 0.5, yeah, I think it's correct. So this is your. Now, if you want to find VOC using this mesh analysis technique, you have to write VOC I1 and I2 as well.
Excuse me, sir.
Yeah.
So if we use here node analysis, then what will be our Vx? V1?
If we do analysis, how we can
Vx?
Yeah, if you are doing mesh analysis, that sorry, in analysis, that's even easier, right? Because if you are trying to find VOC, that is voltage,
yes,
the voltage of this node is 18 volts. You can write this as V1 and this one as V2.
Yes, sir.
Now, all you have to do is VOC is basically V2 minus 0, because the positive terminals voltage is V and the negative terminals voltage is 0. Node analysis, you're basically done.
And Vx will be our V1, right?
Your V2 will be your VOC.
Yeah, and we have to find Vx as well. Variable.
Oh,
so
Vx, and Vx will be V1. Yes.
Yeah. Okay. That's
yeah. So if you're doing mesh analysis, what you can do is, I'm going to this as well, so no need to worry. I think some of you have made a mistake here, so I'm going to show as well. But if you are doing mesh analysis, this would have much easier.
Correct.
This is because the mesh analysis is much easier here, right? Because you have only two loops, and one, you have seen that I have already solved and I don't even need to use the circuit solver or equation solver, right? So that is why I'm doing mesh analysis. There is no other reason, basically. Okay. The way I'm seeing is that we have two loops here which are not connected that much. Okay, so that is why, and one of them has a current source here. So I find that easier to do with mesh analysis. Okay, so if we are doing mesh analysis here, the value of voltage of this, so VA minus VB, right? And again, if you are trying to convert voltage in terms of, you are trying to write voltage in terms of resistance, and you can see that like before, if I wrote it V1 and this one V2, you can write as V2 minus 0 or V minus V1 plus V1 minus 0. If you are not able to see that this voltage is basically the addition of these two resistors. Okay. So if you are trying to do that, the V2 minus V1 part will be 2I, because this is the positive, this is the negative, and again this is positive, this is negative, so you have plus 3I1. So if you are using mesh analysis, this would have been much to solve, given that you can figure out how to write VOC in terms of I1 and I2. 2 times I2 is minus 1.5 plus 3 times 2. The value here is minus 3 times plus 3. So this is 3 volts, right? So VThevenin is 3 volts. This is the value of VOC is basically 3 volts. Now, if you are doing node analysis, that would have been also easy, not that hard, but most of you have made some mistakes here. Let me show mistakes. We had a resistor, 3 ohm resistor. Mm. 2 ohms, and we have a current source 0.2 V, node A, node B, and you have to find VOC. Okay, so if you are doing node analysis, you don't even need to write a name for this, V1, and this one is V2. So I haven't seen anyone this V2. So there will be a bridge here. There is current going through this resistor because of this loop. Okay, so if you have missed this node, that is not correct. A node. Okay. Okay, so if you are trying to write node equations for V1, what should be that equation? You have 3 resistors here. Somehow, some of you have missed one of these resistors. I don't know why, but some of you have missed this. So we have 3 resistors here. And the connected to 8 volts. So we have, sorry, 18 volts. So we have 18 divided by 6. Then we have this 3 ohm resistor that is ground. So we get 0 by 3. So I'm not going to write that. And finally, we have this V2 by 2 ohm resistor. But what most of you have missed, this take a look at this node. You have a current source here,
Yes.
and this should be 0.25 Vx equals to 0. Again, the one other mistake is that some of it is plus, but this is not the case. If your current is entering a node, that should be negative. Okay. So this is probably the most common mistake that a lot of you have. So this is one equation, and for the other equation V2, we have only one resistor connected to V2, so 1, 2 minus whatever voltage is on by 2, and we have this current source again, right? So that is plus 0.25 equals to 0. So since exiting from node 2, we write the positive 2.25 Vx. Okay. So equations, and you have Vx here. You can write Vx as positive terminals voltage minus negative terminals voltage, V1 minus 0, which is basically V1. So if you just replace this Vx with V1, you are basically done. You have only two equations, and you can easily solve them to get the result. Okay, finally, here should be V2 minus 0. So nodal analysis is so easier. Just remember there is a current source here that you need to consider. Also, some of you have tried to super node here, but this is not a voltage source, or there is no floating voltage source in this whole circuit. Okay, so there will be no super nodes here. Okay, so there will be no super nodes.
সুপার নোড কি শুধুমাত্র ফ্লোটিং ভোল্টেজ সোর্স থাকলেই হবে?
Yes, only if you have a floating voltage source, only then you need to do super nodes. Okay, other than that, you don't need to do super nodes at all.
So transient analysis take circuits
হ্যাঁ, transient analysis যাব। আজকে একটু ইয়াটা দেখিয়ে যায়, আপনাদের Theveninটা দেখিয়ে যায়। I'm just showing Thevenin because in Thevenins while doing transient analysis, okay? And since this is a review, I'm just going through them one by one. Okay, there is one other scenario here. The 3 volts here. So the Thevenin's voltage is 3 volts. If you have a non-zero here, you can do short circuit current, right?
Yes.
You need to find ISC, and then you can find RThevenin by doing VOC by ISC. Okay. So since we don't have non is not equals to 0, so we will do short circuit current. Okay. And if we had VOC equals to 0, need to current. Okay. Test current source or test voltage source. Okay. Whatever. I have taught you using test current source, and that's enough. Okay. By the way, for Thevenin, for example, in it's in last quiz, I think your ISC was 0 on the circuit. So what I'm basically, if you have an inductor and you're trying to do, say, Norton's theorem, or basically finding out current first. Okay, so if you have an inductor here, you can find the VThevenin by doing VOC and RThevenin by doing VOC by ISC. If you don't have a non-zero or non-ISC, right? Okay, so what I'm trying is this is also holds for ISC. Okay, if you're trying to solve for ISC first, so for example, if you're trying to do ISC first, that's also fine. Okay. If your VOC is 0, ISC all. This is always true. If your VOC is 0, ISC is also 0. So for example, while doing transient analysis, say equals to 0. That means your VOC is also 0 and you have to do test current source to find out RThevenin. Some of you have RThevenin by doing VOC by IC, but have divided by 0. Something divided by 0 is not 0. That's actually undefined. Okay. Make this. So please don't make this mistake. If you have 0 ampere circuit current, that means your open circuit voltage is also 0. Okay, so you have to do test current. So you may write that you are trying to find, say you have found ISC, and if you have ISC non-zero ISC, you can do VOC to find out. And if you have a 0 ampere for short circuit current, you need to do test current source. Ampere current. This is what you need to do. Okay, so if you're doing short circuit current first, some of you have tried to do short circuit current first. Okay, so that's also fine. Okay, we need to find short circuit current for this circuit. And if we are trying to find current using mesh analysis is better, right? So we have 18 volts here, 3 ohm resistor here, Vx voltage here. 0. Vx here, 2 ohm resistor here, and we had node A and B. So for short circuit current, in the short circuit current going through this branch. Okay, so if you are having this new circuit, if you are working with this new circuit, look at this, and you may just to your equations or your circuit. For example, we now have 3 loops. We only had 2 loops before, but right now we have 3 loops. And basically this IC is okay. And what about this Vx? Right.
I1 minus I3.
Yes. Not just I1 minus I3. You also have to multiply by that by 3. Remember that voltage cannot equal to the resistance. Okay. So this is your equation. And again, remember the direction passive sign convention. So you have to find the current in this direction because positive is. Okay, so your current should flow from positive terminal to negative terminal through the resistor. And in that direction, the current is I1 minus I3, not the other way around. And again, you have I2 equals to minus 0.25 Vx. You can replace the value of Vx there. And for mesh 1, we have again 2 resistors connected to mesh 1, 6 plus 3 minus, we only have a common resistor with mesh 3, 3 I3 minus 18 equals to 0. Okay. And for the last, and lastly, we also have to write equation for mesh 3. 2 plus 3 minus 2I2 because the 2 ohm resistor is connected to mesh 2 and the 3 ohm resistor is connected to I1 equals to 0. Okay, so you have to solve these equations to get the result. Okay, so yes, one other thing, if you count the equations here, so you will get one equation from mesh 1, one equation from mesh 2, and the other equation from mesh 3. Okay, so you will have 3 equations. This is your equation 1, this is your equation 2, and this is your equation 3. If you have other variables like Vx, you will also have an equation for them. So in total, you will have 4 equations here. Okay, so count the number of variables, count the number have a mismatch. So if you have a mismatch, that means you are missing one or two equations. Again, you can do this by using node analysis also. So if you are doing node analysis, if you're doing node analysis, this is 18 volts. This is say V1 and the whole node is now ground, right? This is not V2 anymore because this is connected to ground right now. Okay, so you only have to solve for one node. And that node equation should be 1/6 plus 1/3 plus 1/2. Because all three resistors are connected to V1 and minus 18/6. And the other two resistors, the other side of the two resistors is basically 0 volts. So I'm not going to write that 0/2 and minus 0/3. And you have a current source here, minus 0.25 Vx equals to 0. And again, you can write Vx as V1 minus 0, as the positive terminal voltage is V1 and the negative terminal voltage is 0. So Vx is basically V1. So you can actually write this as V1 again. So all you have to do is solve this equation. Now, if you find the value of V1, which we can actually do, this is 1, so this is 0.75 equals 3. So V1 is probably 4 volts. Don't make my calculations are correct, but I think they are. So this is 4 volts, okay? One is 4 volts. We figure out the current through here. Some of you have tried to solve this by doing node analysis. And if you're trying to find ISC, well, you have to find the current. How can you find this current? So basically you can do KCL here, right? You know this current going through here, Vx, and the value of Vx is V1. So that is 0.25 times 1, which is, sorry, the value of V1 is 4 amperes. And the current through this resistor is basically 4 volts minus 0 volts divided by 2, which is 2 amperes. So if you do KCL here, you can find the value of ISC. 1 ampere current is exiting this node, class 1. This 2 ampere is entering this, and the ISC is also exiting this node. This is equals to 0. So if you try to do this, you will see that the value of ISC is 1. Okay, so if you're doing node analysis, this is also quite easy. And finally, that means your RThevenin is VOC 3 volts divided by 1 amperes, which is 3 ohms. Okay, any questions?
I have a question.
Yeah.
Does the ISC is parallel with Vx 3 ohm, right? So we can find the voltage of, sorry, in parallel combination. Okay, sorry. So how does 2A becomes in 2 ohm?
Oh, how can how did I get this 2 amperes?
Yeah.
Here you have a ohm resistor. What voltage on the right hand side? The voltage here is 4 volts, right?
Yes, sir.
On this side. On our circuit, I'm just writing it here to show or focus on this, right? So this is connected to our ground, right? Means this is 0 volts, right?
Yes.
So what's the voltage difference? 4 minus 0. So the current is the voltage difference 4 minus 0 divided by 2 ohm, okay, which is 2 amperes.
Okay, sir.
Right? Okay, some of you might think that this wire is parallel to 3 ohm resistor or something like that. This is not, because you have a 2 ohm resistor here. This wire is connected between this node and this node, which is basically ground node and ground node, right? So this is just one node. On the other hand, this 3 ohm resistor is connected between V1 and ground, so they're not in parallel. Okay, if they were in parallel, they should be within the same nodes. Okay, so this is how you should have done your quiz 3. And if you find your VOC and ISC, then you can find RThevenin for this problem. If you didn't find the VOC to be non-zero, so for example, if your VOC was 0, like the other set, then you have to do test current, right? So for example, modify this circuit. Say your problem was this circuit. If you had this circuit there, so you can write, since there is no independent source here, the voltage, current, VOC, ISC all should be 0. Okay, so if your voltage current also is basically include a 1 ampere current source or 1 milliampere if you're doing millikilo maths. Okay, so if you have milliamperes and kilo ohm maths, so this is how you would do. You would do, say, nodal analysis on this problem and find out the voltage of this node and this node. I think you only have these two unknown nodes. So if you solve this, your result VT should be your test voltage, and the value of your test current is basically whatever voltage you or whatever current you have used. So this 1 ampere is basically your test current. Okay, so your RThevenin should be VT over IT, whatever the value of VT, that is the value of V2 you get. Okay, V2 divided by 1 ampere, whatever the value of V2 is your RThevenin, because you are dividing by 1. So if this value negative, it's negative. Okay, so no need to worry about that. So this is how you do Thevenin. Okay, so there is basically no exception. All you have to remember is that if you have 0 ampere short circuit or open circuit voltage, you have to apply test current source. Okay. Now for your transient problem. Okay, so let's discuss your quiz 4 problems. I don't know if I have a copy of the question with me right now. Let's try to make one problem. So
sir, queries channel কি দিব, মানে আমার কাছে ওই প্র্যাকটিস থেকে কয়েকটা প্রবলেম আছে। queries ডিসকর্ডে কোয়েশ্চেন,
ডিসকর্ডে কোয়েশ্চেন দিবেন। ওকে, দিতে পারেন, সমস্যা নেই। So what you are asking is basically if you have what to do, right? So you had a switch like this in your quiz 4, but I don't know why you are intuitive. Whatever you think you are thinking is correct. Okay, just trust yourself. Whatever you think is happening here is happening. Okay, so basically if you have this type of situation, is always you will be given two states. Okay, don't worry that what will happen in between or etc. Okay, so you will have an initial situation, you will have a final situation. For example, what's the initial situation here? Well, circuit was bottom part was basically disconnected. Okay, so this is your initial situation. And finally, what happened was that the switch changed its from there to there. Okay, so this is how it should be connected, because take at the arrow. So this is basically kind of like door, right? So you have a door here. If your arrow is moving in this direction, so if you're kind of moving this door, what you are doing is basically hinging on this point, right? So this point is basically fixed. This is your hinge, and if you rotate it, you reach this point, right? So this is your final circuit. So this could be a given switch in your question. Okay, so this is nothing too difficult in my opinion. Okay,
স্যার এখানে ডিসকর্ডে কোয়েরি চ্যানেলে আমি একটা পিকচার দিয়েছি, ওখানে 7.44 নাম্বার কোয়েশ্চেনটা আমি ওখানে যখন এবি থেকে আমি হচ্ছে গিয়ে সুইচটা অফ করে ফাইনাল সুইচে আসবো, বি এর সাথে কানেক্ট করবো পরে। তো এখন এখানে আমাদের ইনিশিয়াল সিচুয়েশনে যখন আমি ইনিশিয়াল সার্কিটটা করবো, তখন 30 ভোল্ট ভোল্টেজ সোর্সটা আমার কাউন্টেড হবে, আর যখন আমি ফাইনাল সার্কিটটা আঁকবো তখন 12 ভোল্ট ভোল্টেজ সোর্স মানে কাউন্ট হবে। কিন্তু আমরা তো একটা ভোল্টেজ সোর্স দিয়ে শিখেছি।
হ্যাঁ, সমস্যা তো না, আপনাদের একটা ভোল্টেজ শিখেছে এরকম কি নাই?
কারণ স্যার আমাদের প্রথমে হচ্ছে কি ওপেন সার্কিট, যেমন এখানে তো ক্যাপাসিটর আছে, ক্যাপাসিটর থাকলে আমাদের একটা ওপেন সার্কিটের ভোল্টেজ বের করতে হয়। তারপর হচ্ছে তারপর মোটামুটি একটা প্রসেস শেষ হলে ফাইনাল সার্কিট থেকে আমাদের হচ্ছে আরথেভেনিন বের করতে হয়, বেসিক্যালি রোধটা বের করতে হয়। তো এখন আমার প্রথমে যদি ইনিশিয়ালি 30 ভোল্ট সোর্সটা কাউন্ট করে ভিওসি বের করি, তারপর হচ্ছে কি পরের স্টেপে ফাইনালটা থেকে মানে 12 ভোল্ট সোর্স যখন থেকে যাচ্ছে না, ওখান থেকে ক্যাপাসিটরের মধ্যে চার্জ আসার কথা না বা সামথিং, এই কনসেপ্টটা ক্লিয়ার না। তো তখন স্যার আরথেভেনিনটাকে আমি নরমাল এই প্রসেসে বের করবো যেভাবে বের করি, যে মেশ অ্যানালাইসিস বা নোডাল অ্যানালাইসিস করে
যেভাবে করেন এক্স্যাক্টলি ওভাবে। ওকে, লেট মি রিইটারেট হাউ টু ডু ট্রানজিয়েন্ট অ্যানালাইসিস। ওকে,
ওকে স্যার।
One situation, first of all, you have capacitor here, right? Should you write the equation for voltage or current? So you focus on
voltage.
The question has asked you for current, but still what you should try to do is find this voltage. Okay, so if you know this voltage, so this okay, I'm sorry if I'm writing it very crudely. Sorry. So if you find the value of this voltage, it's easy to find the value of current. We know to C dV dt for a capacitor. This is the equation for a capacitor. So if you know the value of the equation for V, you can differentiate that in terms of T and phi. Okay. So yes, we should be doing should be solving this circuit for finding V. Okay, so this is our target. So in order to do that, you should draw an initial circuit, and from that you should find VOC, which should be your V0. Let's see V0 as well as for the final circuit, you should be finding VOC again. Okay, V infinity. And you should also be finding RThevenin here, which you will need to find tau. Okay, because tau equals to RThevenin times C. Okay, so that's it. So what's the difficulty here? I don't understand. After you have done that, the equation is very simple, equals to initial minus final e power minus T by tau plus V infinity. This is the equation for our voltage, and then you can current using this equation. So let's try to solve this problem, okay? I am going to solve this problem. So, yes, this is our circuit here. So what is the initial situation? This is how the circuit is connected. Okay, so I think is connected. So since this voltage source is basically doing nothing, it's connected to anything, it will have no effect on the circuit. We're just going to remove it, okay? So this is our circuit, and how can we find the voltage? Well, you have to find VOC, right? You have to find VOC, and to do that, remember the load, your load is this capacitor. Okay, so this is your capacitor, this is your load, this is your capacitor, and you need to find VOC here. Dropping ramp. কি বলতে যাচ্ছেন? আর কোনো কোয়েশ্চেন থাকলে বলতে পারেন।
না স্যার মনে হয় কারো মাইক্রোফোন অন হয়ে গেছিল।
Okay, I'm muting you all. So if you have any questions, please unmute yourself and ask them. Okay, so your capacitor is your load, and you have to open it and find the voltage. Okay, so we are basically and find out VOC. Okay, so VOC, this is what we are trying to find. And if we try to find the VOC, do it in the multitude of ways. I can see that this is a volt divider problem, right? So you have 30 volts here, 6 ohms and 3 ohms are the only resistors in series here, and across the 3 ohm resistor. So that is very easy to find. 30 volts will get distributed between 3 and 6, and you're trying to find the voltage 3 ohm resistor. Okay, so if you solve this, you should get 30 volts times 3 by 9, which is 1/3, and you should get 10 volts. Okay, so your initial VOC is 10 volts. So that means this is your V0. Okay, this is your initial circuit. So this is step 1. Initial circuit, the VOC is your 0. Okay, is this clear what I have done here? So your V0 is 10. Okay. Next, we should do final circuit. Okay, so for final circuit, the switch position will change from this position to this position. Okay, so that means this part is basically non-existent. Okay, and this is your capacitor is your load. Again, you're trying to find VOC here. So that is what I'm going to do. I'm going to open it up and find the VOC here. Okay, so again, you have two resistors, 6 and 3 ohms, they're in series, and we're trying to find the voltage. You can do it by using voltage divider rule, which is 4 volts. I hope I don't need to show the calculation again. So this VOC of the final circuit is V infinity. Okay, this is your V infinity. Now, most of you you have started after this point. After you have found the VOC, I don't know how you try to find RThevenin. Okay, so there are multitudes. So VOC divided by IS method. Okay, so I think that's the safest bet. So again, the final circuit, let me draw the final is like this, and this part is removable. And now you have to find the short circuit current. Can you tell me where I should short circuit? Yes, again, wherever we did the VOC and or wherever our capacitor is, that is our load. Okay, this current should be our ISC. Okay, so now you had some problem in some state, kind of this scenario. This was kind of this scenario. So you have to find short circuit current. If I write the short circuit current is basically 12 volt divided by 6 ohm, that is 2 amperes. Can you guys understand? So take a look here. So this is basically 3 ohm resistor and a 0 ohm resistor in parallel, right? Wire is basically a 0 ohm resistor. So 3 ohm and 0 ohm is basically in parallel is basically 0 ohms. Or the other way to see this is that if you have a wire connected to a resistor on two ends of the resistor, if this is your ground, this is also a volt. So this resistor, because there is no voltage difference. So this is basically completely useless. Okay, so you can do node analysis, mesh analysis, or whatever, but if you can see these things, solve. Okay, so you will have a loop with some resistor. Okay, so you have the value of ISC, that means Thevenin is basically by ISC, the IS 2 amperes, whatever the VOC, is it this VOC 4 volts or the previous VOC 10 volts?
First one, 10 volt.
No, last one.
No, sir,
Because
last one.
you are analyzing final circuit. Why are you trying to bring this 10 volts here? This was a complete different circuit. This one was with 30 volts. Why should I bring this? Okay, so these two circuits are basically same circuit. There's 3 ohm resistor here, but which is basically non-existent. You should use these 4 volts. Okay, so the value of RThevenin is 2 ohms, 4 divided by 2. That means the value of tau is RThevenin times C. RThevenin is 2 ohms, and our capacitor was 2 farads, if I remember correctly. Yeah, so this was 2 farads. 2 farads. So for tau is called time constant. So again, remember this name because in your final question, we may ask you to write what the value of time constant is instead of writing out this is tau. Okay, so remember this is called time constant, and the unit is of course the unit of time, which is seconds. So now all these values, all you have to do is write the equation for VT. Okay, so step 3 is your VT, V0 minus V infinity power minus T by tau plus V infinity. So your value of V0 was 10 minus your value of V infinity was 4 volts. So I'm going to write it here. And you have e to the minus tau. The value of tau is 4 seconds. Okay, so this is your equation. Okay, so if you want, you make them look a bit prettier. So this is 6 e to the power minus 0.25 plus 4, however you want to write it. Now, if you may be asked to draw the voltage curve for this, or the graph of this, and that is very easy. Just look at the initial voltage and the final voltage. Initial, so it should start from some value 10 volts, and that value is 10 volts, and it should end after infinite amount of time, should reach 4 volts. 4 volts, right? So after infinite amount of time, this should reach this 4 volt level. So starting from 10 volts, it should reach 4 volts for VT. That's it. And if you're trying to find IT, IT is basically dV dt. I'm just going to write dt. So the value is 2 farads, right? And ddt of V, equation of V is this one, 6 e to the power minus 0.25 t plus 4. So 4 volts, I guess, right? So ultimately, I'm just going to remove the units and going to write as amperes, because all of them are in SI units. So, okay, let's do this differentiation parts. So if we do differentiation on this is a constant. Okay, constant times something. Something is basically 6 times whatever is the differentiation of the remaining part. Okay, and the remaining is e to the power mx in e to the power mx format. In that case, the m comes to the bottom, and you have e to the power minus 0.25 t. Plus, you also have to take a derivative of this 4, and the derivative of a constant is basically 0. Okay, this is not a function of t. That is why the derivative is 0. Okay, and if you multiply, I think you should get 6 times. So this is 3, right? E to the power 0.25. This is your equation. If you are trying to draw this again, just do this. I0, what's the value I0? What's the value of I0? I think someone's mic is turned on. Kaji Sadman Sakib, can you please turn off your mic? So you're trying to draw this again, what we should try to do is find out the initial current and the final current. Okay, the initial current and the final current, and you draw that. Okay, for example, the value of I0. Do you know what the value of I here? If you don't know what this what's the value of I0 here, e to the power 0 base, that's 1. You can also use your calculator, okay? And write this in your calculator. You can use the calc button. I don't know if this simulator has the calc button. Yeah, okay, it has. Okay. So normal math, I can write -3 times alpha.
স্যার আপনি ইন্টারনেট অনেক প্রবলেম করছে।
I think mine is fine. I can hear myself. Okay. Did you miss any part?
জি স্যার, যে I0 যে কথাটা বললেন ওইটা হচ্ছে আমাদের টাইমটা, জাস্ট টি এর জায়গায় আমরা হচ্ছে 0টা বসাচ্ছি।
May be asked to find different values at different. So, for example, I might ask you what's the value of I5, meaning if you put the value t is equal to 5, what's the value of the current? And the way to find that out is basically 3 e to the power 0.25 times 5, right? And you just
Yes,
put in the value of 5. And you can solve this well just write this function like this. You can use this calc button. So there is a button called calc, and whatever the value of x you put in, you will get the result. Okay, so for example, if I put in 5 and press equal, this is the value of our 5. Okay, minus 0.86, basically 86 ampere. So for example, I was trying to find the value of I0. Okay, I0 basically gives you I minus 3, and I want to get the value of I infinity input infinity. Well, you probably don't have an infinity button on your calculator, so you can just put in a large value. Okay, so if you put in that large value, look, the value is basically 0. Okay, so this graph I should start from minus 3, end up at 0. Okay, it will try to reach 0. Okay, so if I try to graph this, okay, so if I try to graph this, the point is basically minus 3, somewhere like this, minus 3 ampere, and the basically 0 amperes, right? This is basically 0 amperes. So it will try to reach that 0 ampere line for IT. That's it. And you can also try to find the value of power by just multiplying the current and this part, and if you multiply this with your minus 3 e to the power minus 0.25 t, you will get your power. That's it.
So sir, if I try to draw every graph for V and I, and the I will always be reverse of V. I mean in the graph. Or it is just for this particular graph that we have seen.
No, this is basically for this particular graph. Okay, so there is this, basically what I can tell you is that the capacitor's current will always try to reach 0. Okay, so the capacitor's current will always try to reach 0. It may start from negative value or positive, okay? But it will try to, capacitor's current will try to reach 0. Because remember, a capacitor finally becomes an open circuit. So what's the final current? 0, right? So after it becomes an open circuit, the final current is 0. Similarly, an inductor tries to become a short circuit. So the final voltage here, the final voltage, 0. They basically, okay. So that I can tell that the current should, this infinite current should be 0. Okay, but that doesn't mean that this voltage current should be 0. Okay, so this is basically meaning saying that the voltage is the capacitor is being charged to 4 volts. Okay, so this is from discharging from to 4 volts. Okay, so this doesn't always have to end up at 0. Okay, but the current has to end up at 0 for a capacitor, but that doesn't mean voltage has to. So to get here is just don't worry about what values you are getting. Okay, just try to follow procedure and you will get the correct answer. That's my take here. In your transient analysis circuit, you'll have an initial situation and no situation, and you will have no other situation. Okay, so the circuit will the switch will be into. Okay, if you have a switch like this, basically 3 points, it might be from switching from one position to the other, or you can have just one switch opening or closing. So the other position might be something like this. Draw it here. Okay, so maybe this is just an opening or closing switch. Okay. Any questions regarding transient analysis? Okay.
Why
If you
we
had
are calculating I5 here?
I5, oh, you might be asked to do that. Okay, you might be asked, okay, what's the value of I5 here? This might be asked, say asked in the to do this in the procedure. Okay, so this is just a like, what's the value? What's the value of I5?
Okay.
Then this is how you calculate. Okay, the question regarding transient analysis.
স্যার আমাদের হচ্ছে যেই পার্টের সাথে আমাদের সুইচটা কানেক্টেড থাকবে ওইটার বাহিরের যে অংশগুলো আমাদের দরকার নাই ওটা আমরা অ্যাভয়েড করতে পারবো, মানে এটা মানে ক্যালকুলেশনে আনবো, যেমন হচ্ছে
If you try to bring that in the calculation, that's basically not necessary at all. Okay, so this is in general true. Okay, so to have a circuit something like this, this is open at this terminal. Since there will be no current through this loop, this loop is basically useless. Okay, so that is why we are removing that part. If we have a unnecessary part, we can basically remove this, because this part, well, where is, you had a voltage source, 30 volt voltage source here. If you want, you can do maths using that. Try to do, say for example, let's try to do mesh analysis here. A complete mesh here. We have a complete mesh here, but do we have a complete mesh here? Because this is broken. And even if you try to write this as a current, basically zero, because this is open, right? If you have some current, where will that current go? There is no current. So the value of the current is zero here. So there is no point in basically dwelling on this clanging part. Okay.
Sir, can you solve the inductor problem? Preferably the quiz 4.
Sure. Okay. 4, you had this circuit, right? So we had set two.
There was inductor circuit, sir, I guess.
Yeah, there. I think we already have. This was the question. One of your sets, at least. I remember that. 3 ohms plus 4. So this is probably not a good question to start with. There is a reason why. You have to find this V. Okay, and there is this I naught, and it is this. I changed it up, and in that process, I messed something up. Okay, so the result was completely zero. But try to look at this problem. Okay, doesn't matter whether the value was zero or not. Again, you have to follow the procedure. Whatever the problem is, if you follow the procedure, you will get marks. Okay. Of course, if your value is not correct, you will get some marks will be deducted. You have to procedure. Okay. Step 1, you have to find the initial circuit. Right. Let me copy this before I edit this. So I am going to start it by solving the initial circuit. Okay. So initially, what was the situation? This is the connection, right? So before, Okay, so again, you have this part hanging out, so you don't need this 8 ohm and 20 source. I have this part as well. Okay, and you have to find this voltage. But if trying to or whatever you're trying to find, you have an inductor here. So what you should try to find is this current. Okay, what's the value of this current? I'm going to name I, typically write inductors with L. And if you know this current, can you find V?
Yes,
Can
sir,
someone
we
tell
can
me
find
what's the
V.
relationship? Yeah, what's the relationship between V and IL?
So resistor into
Sir,
IL.
so for this, if we have a
So the
complex,
2
I
ohm
mean,
into
the
IL.
equationের মতো আছে তাহলে হচ্ছে L into DI divided by DT এটা divide করতে হবে। আর
L
যদি
into DI divided by DT. Okay, let me tell you something. What's the equation? What this equation of?
sorry,
This
sir.
is the equation of inductor, right?
Yes, sir.
Is this an inductor?
No, this is not. Sorry, sir. এটা তো রোধের জন্য। হ্যাঁ, sorry. তাহলে V equals to I R হবে না যেটা।
Yes, I times R. So the current is basically IL. So the current is same, right? Because you have series connection here. So
Yes,
this
sir.
should be 2 times IL. So let me clear it up. If I asked you to find the voltage across this inductor, okay, so that is the voltage, then you should do the IL by dt. Okay, LDI by dt. Okay. Other than that, we are not asked to do the voltage. We are not asked to find the voltage of the inductor. We are asked to find this voltage. Okay. So whatever, if you find the value of IL, we are done. Okay. So we are going to solve for this IL and this initial current, initial circuit again. So if you are doing transient analysis with an inductor, first you should solve the circuit and you should try to find the ISC, which should be your I0. Again, for the final circuit, you should find ISC, that should be your I infinity. And you should find your R Thevenin, which will give you your tau, because L by R is your tau. Equation I L basically. So let me write it as IT. 0 minus I infinity minus t by tau plus I infinity, right? Since name this current through in IL, I'm just going to write them as IL instead of I. Right? The equation of current is basically initial minus final times e to the power minus t by tau is plus the final current. Okay, so for this initial circuit, what we have to do is find the short circuit current. Can you tell me to find the short circuit current?
Sir, in the inductor replace that short circuit.
Yeah, wherever you have your load, right? So you should short this circuit and base, which is your short circuit
wherever
current, by the
I
way.
have my load or wherever I have my switch.
Wherever you have your load, that is how you did your Thevenins, right? If you had a load, you would remove that to get an open circuit and you'd short that to make short circuit.
Yes, sir, for the initial part.
For both parts, okay, for both parts, you are doing a Thevenin's problem here, okay? So basically we are converting this transient problem into two different Thevenin's problem. So when you were doing Thevenin, you did not have any switch at all. So of course you are not going to find the short current through the switch. You have to find the short circuit currents through the load. That means the capacitor current. If you have an inductor, okay? So you have to find the current through this
Sir, one more thing,
inductor.
in one of your like following recorded sessions from last semester, you somewhere wrote that I final minus I initial, and lastly plus I initial. So that was wrong, right? Because it is I initial minus I final.
So I think that equation can be written in different forms. For example, I can write it as I infinity minus L infinity. So you have to write a minus here. So mistake or not, but if this was the form, that can also be written in this way. So it doesn't actually matter. Okay,
Sir,
so
it
I
wasn't
think
written in this way. It was like straight, just like the equation you wrote right here. But instead of like I initial, you wrote I infinity minus I 0.
okay, I have to see that. I can if I'm, but yeah, this is the correct equation. Okay, even if I did, this is the correct equation.
And in that case, like, sir, in this case, if you're like adding I infinity in the very last plus I infinity, it would be 0, right? But it wasn't 0 at that time.
No, why should it be 0? If it was 0, why should I be doing this, all this stuff? I could write 0 here. I shouldn't. Why should it be? I don't understand. We can discuss it. It's fine. You're saying 0?
স্যার বুঝি নাই, কথা আটকে আসছে।
আপনি কি চাচ্ছেন যে মানে বলতে চাচ্ছেন এইটা 0 হবে?
আমি বলছি যে স্যার আপনি মানে ওইখানে ইকুয়েশনটা এমন ছিল যে I infinite minus I 0, I 0 তো একটা ভ্যালু আছে, বাট I infinite তো শর্ট করে দিলে আর কোনো ভ্যালু থাকে না। ইটস বেসিক্যালি I 0 minus I infinite না।
নো, ভ্যালু থাকতেই শর্ট করে দিলে ভ্যালু থাকবে না কেন? আপনি কোনো কিছু শর্ট করে দিলেন, ইফ ইউ শর্ট সামথিং, ইট ডাজন্ট হ্যাভ এনি ভোল্টেজ
স্যার ওপেন সার্কিট করে দিলে,
okay, open circuit করে দিলে of course there is no current, but you are not doing open circuit. Okay, so okay, just try to follow the procedure. If you are having trouble, write scheme like this first. Okay, try going to do. Okay, I think if you try to write it out like this, you will make less mistakes. For example, if you do short circuit, you should you make it 0, but that doesn't always
শর্ট সার্কিটটা শুধু I 0 সময়, বাট সুইচটা ওপেন করে দিলে তো তখন এটা ওপেন সার্কিট হয়ে যাচ্ছে না, তখন তো স্যার লেফটের পোরশনটা পুরোটাই বাদ হয়ে যায়।
কেন আপনি সুইচ কেন ওপেন শর্ট করতেছেন? সুইচ তো সুইচের পজিশন দেখে আপনি একবার ইনিশিয়াল ফাইনাল সার্কিট আঁকার পরে সুইচ বাদ, সুইচ নিয়ে আপনার কোনো কিছুই করা লাগবে না। Then you have to do theory, right, to find circuit current for the open circuit current.
হ্যাঁ স্যার, ওপেন সার্কিট মানে তো স্যার মানে সুইচটা অফ, তাই না?
সুইচ নো, আপনি ওপেন সার্কিট করবেন যেখানে আপনার ইন্ডাক্টর বা ক্যাপাসিটরটা থাকবে। Okay, so you have your circuit here. Okay, this is your switch. Say this is your inductor. Okay, so
স্যার ভিডিও অনেক ল্যাগ করছে।
ওকে, একটু ল্যাগ হবে কারণ হচ্ছে আপনার আসতে সময় লাগতেছে। হ্যাঁ,
মানে প্রবাবলি আর কি ডিলে হচ্ছে, আপনি কথা বলছেন হয়তো স্ক্রল করছেন আগেবার ওয়ের সেইং।
সকালের আগে ভিডিওটা পাওয়া যাবে?
হ্যাঁ, ভিডিওটা দিব, বাট देयर इज আ ভেরি হাই অ্যামাউন্ট অফ ল্যাগ।
প্রচুর ডিলে, মানে এতক্ষণ মাত্র এখন হচ্ছে সার্কিটে দেখা যাচ্ছে।
I can see that as well. আচ্ছা, যাই হোক, so what I'm saying that দেখেন আপনার যদি একটা কি বলে এরকম সুইচ থাকলো, আপনি কি এখানে ওপেন শর্ট করতেছেন? এটা তো আপনি ধরেন এরকম কানেক্ট করতেছি, সো ইউ হ্যাভ টু সার্কিটস, রাইট? একটা ধরেন হচ্ছে ওপেন অবস্থায় আছে, অ্যারোটা যদি এভাবে থাকে, দিস ইজ ইওর ইনিশিয়াল সার্কিট। এটা হচ্ছে আপনি ক্লোজ করে দিচ্ছেন। Okay, so I am talking about switch closing, right? For now, I am talking about closing. After you have drawn your initial and final circuit for the switch, okay? There is no function of that switch anymore. ওকে, বুঝতে পারছেন? এখন আর আপনার সুইচ নিয়ে কোনো কথাই বলতেছি না। এখন যদি আমি বলি করো, that means I am telling you to find this short circuit current. এখন আসে নাই, ওকে আসছে। Okay, find this short circuit current. Final circuit, again, if I tell you to find the short circuit current, what I'm trying to tell is find this circuit. Okay, in place of the inductor. For Thevenin, again, you have to find 0. So you open this up and find the voltage here. This is just to find out the R Thevenin, nothing else. Okay, so this is where you find short circuit current and open circuit voltage. Everything is done in place of your inductor or capacitor. Okay.
স্যার, তো এতদিন যে ওই যে ক্যাপাসিটর বা ইন্ডাক্টরের ম্যাথ যে করতাম, তো তখন তো স্যার এটাই করতাম যে ফার্স্ট হচ্ছে কনসিডার করতাম যে সুইচটা হচ্ছে শর্ট সার্কিট, সো বেসিক্যালি এটাতে কারেন্ট যাবে। আর এরপরে হচ্ছে স্যার মানে আর থেভেনিন আর হচ্ছে ভি ইনফিনিটি টাইম হচ্ছে সুইচটা ওপেন সার্কিট, সো তখন দেখা যেত যে কোনো কারেন্ট ফ্লো হচ্ছে।
দেখেন, সুইচ ব্যাপারটা তো প্রথমেই আপনি দুই ভাগে ভাগ করে ফেলছেন, ইনিশিয়াল সার্কিট আঁকাইছেন, ফাইনাল সার্কিট।
ইনিশিয়াল সার্কিটে মানে সুইচটা এখনো মানে শর্ট সার্কিট।
ইনিশিয়ালে এইটা ডিপেন্ড করবে, যেমন এই সুইচের ড্রয়িং এ দেখে কি দেখতেছেন?
স্যার এই
ইনিশিয়াল অবস্থায় কি ছিল?
এইটার ইনিশিয়াল অবস্থা হচ্ছে স্যার ওপেন সার্কিট, মানে কোনো কারেন্ট ড্রপ
ওপেন ছিল, হ্যাঁ, সুইচটা ওপেন ছিল,
হ্যাঁ।
তো এই যে ওপেন আছে, বাট আই এম নট টকিং অ্যাবাউট দ্যাট ওপেন
মানে স্যার এই কেসে তো তাহলে ইন্ডাক্টর বা ক্যাপাসিটর কোনোটাই চার্জ হবে না ইনিশিয়ালি।
সেটা বাদ দেন, আপনাকে তো আমি বলতেছি না এই সার্কিটে কি হবে না হবে, আমি বলতেছি ইউ হ্যাভ টু ফাইন্ড দ্য শর্ট সার্কিট কারেন্ট এট দ্য পজিশন অফ ইউর ইন্ডাক্টর, ঠিক আছে, অর ক্যাপাসিটর। বুঝতে পারছেন? শর্ট সার্কিট, ওপেন সার্কিট ভোল্টেজ, শর্ট সার্কিট কারেন্ট, এগুলো যা বাইর করবেন সব ইন প্লেস অফ দ্য ইন্ডাক্টর অর দ্য ক্যাপাসিটর, ঠিক আছে? বুঝতে পারছেন? যেমন ধরেন এই প্রবলেমে ইন্ডাক্টরটা কোথায় ছিল? এখানে ছিল না? আমি হ্যাঁ, এই যে এই জায়গায় ছিল না?
জি স্যার।
হ্যাঁ, সো এই কারণে আমরা এইখানে শর্ট সার্কিট ওপেন সার্কিট যা করার করব, সুইচ বাদ, সুইচের ব্যাপারে আমরা কেয়ারই করি না। ইনিশিয়াল সার্কিটের পরে আপনি সুইচ পুরো উঠায় দেন, হু কেয়ারস অ্যাবাউট দ্যাট, ঠিক আছে?
তখন আর স্যার সুইচ কনসিডারই করব না।
সুইচের কাজ ওই ইনিশিয়াল এবং ফাইনাল দুইটাতে স্প্লিট করার পরে শেষ, ঠিক আছে? এরপরে আর কোনো কাজই নেই। ওকে, so you have to find this ISC current, and in order to find that current we can do mesh analysis. Okay, let me quickly finish. We still have to find we still have to do AC analysis. Okay,
স্যার এটা কিভাবে ফিক্স করা যায় না ডিলেটা?
স্যার এই প্রবলেমটা শেষ করে দেন, সলভ করে।
আচ্ছা দাঁড়ান, এটা শেষ করি। আর আমার অ্যাকচুয়ালি ফুল গিয়ারটা নাই, এখন কাজ করব, গিয়ারটাই নাই।
স্যার পরে স্যার রেকর্ডিং দেখলো এরকম মানে ডিলে নিয়ে দেখলো,
রেকর্ডিং এ আসলে এরকমই আসবে, বিকজ এটা আসলে আমার ব্যান্ডউইথের প্রবলেম। বাট
স্যার আইএসপি কে কল দেন।
আইএসপি তো না, মোবাইল দিয়ে চালাচ্ছি, এটাই তো কাহিনী। আমি আসলে যে জায়গায় আছি আসলে এখন ইয়া নাই, আমার কাছে ওয়াইফাই কানেকশন নাই। আচ্ছা যাই হোক, লেটস গেট ব্যাক। যেটা বলছিলাম, দেখেন এই প্রবলেমটা, সো ইউ হ্যাভ টু ফাইন্ড আইসি। সো এগেইন the value of ISC is basically I2. Okay, so we need to write mesh equation for these two meshes, and we don't have any super here. প্রথমে মেশ অ্যানালাইসিস করতে গেলেই দেখবেন যে আপনার কারেন্ট সোর্স আছে কিনা। There is no current source here. Okay, so that is why we are completely fine. We should do just KVL on these two nodes. So আমরা যদি mesh 1 এর ইকুয়েশন লিখি, I1 times 3 ohms, there is only one resistor in this mesh, and have resistors here, and the 3 ohm resistor is not part of any other mesh as well. So then we have this 24 volts voltage source. We are hitting on the minus sign, so we write minus 24 volts, and finally we write plus 4 I naught, because this is a voltage source and we are hitting the sign, equals to 0. Another thing, what's the value of I naught here? This is probably
I1 minus I2.
I1 minus I2.
Sorry. Oh.
No, sir, 3 I.
What is I naught? Just tell me what is I naught. See in this circuit anywhere.
Minus I1. So minus I1.
Yeah. So this is your I naught, right? Most of you miss this I1 reason. I don't know why. Okay, so you see that the I1 current is going through in this direction, on the right hand direction. So our value should be minus I1, opposite direction. Okay, so instead of writing I naught, we can write minus I1 on our equation, and this is just one equation. And for the other equation, what we can do is, well, of course, write the mesh equation for mesh 2, I2 times 2 minus 4 minus I1 here. Okay, so from here we can solve the value of I1 and I2. So let's see, the value of I2 is basically minus 2 I1. I1. Okay, and replace the value of I1 from here. So on the left mesh 1 equation, we can calculate the value of I1, because we have 3 I1 minus 24 minus I1 equals to 0. And the value is basically I1 equals to 12, right?
Yes, sir.
So that gives us the value of I2 to be minus 2 times 12, which is minus 24 amperes. It's a negative value, but I don't care, okay? Whatever the value of I2 is your short circuit current and is your initial current.
I1 এর value minus 24 হবে না? কারণ 4 আছে,
I1 এর
একটা
value,
I0 এর মানে I0 এর আগে তো একটা 4 আছে। মানে ইকুয়েশনটা আছে। minus 4 I0.
sorry, I missed. Sorry, I missed that. So that should give us minus 24, and so our value should be minus 24. Okay, so the positive value is the value of I2 is your ISC, or that is your initial inductor's current. Okay, so this is 48. Again, we should repeat this for our final circuit as well. For final circuit, oh, আমি এটা কপি করছিলাম। আচ্ছা, ও ক্লিপবোর্ড আছে I think. So for the final circuit, the switch should be connected like this. Okay, so you can forget there is a switch at all. This is basically your connection now. And this part is useless, except for this one part. What's the value of your I naught? Because you need your value of I naught to put in here, right? Tell me what's the value of I naught?
So
24.
Mm-hmm.
So 24. কারণ I0 equals to minus I1.
I naught equals to minus 5 ohm. Why? Acha, tell me what's the current through this area?
Sir, এটা তো জিরো হওয়ার কথা এখানে যাবে না।
Yeah, this is 0, right?
জি স্যার।
This is just 0. So this is basically just 0, right? Because your connection, there is no connection here. Okay, so this is open, meaning there is no connection here. There is no current. That means 0 amperes of current. So this means that 4 times 0 is 0 volt. Okay, so আপনি চাইলে অনেক কিছু করতে পারেন. A 0 volt voltage source is basically short circuit. You can just reduce this circuit to a very small circuit. Okay, অথবা আপনি যেভাবে আছেন এভাবে ম্যাথ করতে পারেন. ঠিক আছে, so for example, this is our ground. There is two nodes. This is one node, 20 volt. This is another. This is another. Okay, so what's the voltage of this node?
স্যার এটা তো নোডাল অ্যানালাইসিস করে বের করতে হবে।
Yes, but you have a voltage source connected to this node, right?
0 volt.
Yes, sir.
So
Yes.
0 volt.
And what's the voltage of this voltage source? Voltage difference between voltage, the two terminals of this voltage source?
স্যার কোশ্চেনটা বুঝিনি আরেকবার বলুন।
দেখেন এই ভোল্টেজ দুই টার্মিনালের মধ্যে ভোল্টেজ ডিফারেন্সটা কত?
স্যার উপরটা যদি V1 হয় আর নিচেটা যদি V0 হয় তাহলে হচ্ছে V1 minus V0 0 হ্যাঁ 0।
This is 0, right?
জি স্যার।
That's what I'm getting at. So this is 0, and this is some value that we need to figure out. That should be our V, but we're interested in our IL first. Okay, or this is our we need to find short circuit current again. We need to find short circuit current, and this short circuit current will be our infinite current or our final current. Okay, so in order to find that, we can just see what's the value of this voltage. You can do node analysis on here and find that this is basically 0 volt. What I'm trying to get is that if you are convinced the voltage here is 0 volts, this is short circuit, and you have 0 volts here, 0 volts, 0 volts here. So the current here is also 0 amperes. The result will be 0. Okay, so you can do node analysis, mesh analysis, etc. to find out this is 0. What I'm trying to say. Okay. Is there anyone who didn't follow my logic? Okay, forget that. Let's do node analysis. I think this is problematic for some of you. So you have to find that you need the value of I naught to put. So this is 20 volts. This is this is V1. This is V2. Well, this is not V2. This is basically one single node, right? And if you're trying to do node analysis and write KCL where you have a voltage source connected to a node, can you write KCL at V1? You cannot write KCL if you have a voltage source connected to a node. This is a grounded voltage source. So this side is volts. Let me reduce it. This is basically 0 volts. That is saying that the difference between these two terminals is 0. And you have 0 volts here, so the other side is 0 volts as well. That is what I'm trying to say. And if that's the case, what's the current? Well, current is basically current through this 2 ohm resistor is. Okay, so the 2 ohm resistor, the current through the 2 ohm resistor will be the voltage difference between the two terminals, 0 minus 0, because this is connected to ground, divided by the resistance, which is basically 0. That is what I'm trying to say. And if you are comfortable with mesh and current, which is also a good choice because you are doing mesh analysis. This is I1, this is I2, and basically your I2. And if we write the equation on the right hand side, let's write the equation on the right hand side. We have I2 times 2 minus 0 equals 0. This directly gives you I2 is equals to 0. That means basically IL infinity should be 0. Okay, so in both ways you get 0. I hope that's understandable. So let's recap. We did the initial short circuit current. So we wrote the circuit. We found out the short circuit current. This is the initial circuit. That is why this is I0. Okay, and the value, what was the value? 48 amperes. So value is 48 amperes. Next, we had to find I. Okay, so we had to find I infinity, which we got to be 0 amperes. Next, we have to find R Thevenin. And for that, what we need to do is basically find the VOC, right? Is that correct?
Yes, sir.
No, that is not correct. Because your short circuit current is 0. Your short circuit current is 0, right?
Yes, sir.
That means
Yes,
your
sir.
open circuit voltage 0. So your value of R Thevenin is 0 by 0. And you will also get 0.
We need test source.
So yeah, you need test source, right? So let's do that again. So this is your final circuit. And I'm just going to draw this part. So if you remember that your voltage, 0 volt voltage source, basically equivalent to short circuit, it is much easier to do that way. Okay.
স্যার একটা জিনিস মনে রাখার জন্য একটু জিজ্ঞেস করতেছি স্যার, আমাদের আর থেভেনিনটা আমরা সবসময় ফাইনাল সার্কিট থেকে বের করবো না, যেখানে
ইয়েস, এটা আপনাদের ক্লাসেও বলেছিলাম, ঠিক আছে? আর থেভেনিন অল ফাইনাল সার্কিট আমি বলেছিলাম না, আপনারা মোস্ট অফ দ্য টাইম কোন সার্কিটটা নিয়ে কাজ করবেন? আর থেভেনিন নিয়ে আপনারা কাজ করবেন, মানে ফাইনাল সার্কিট নিয়ে আপনারা কাজ করবেন। ইনিশিয়াল সার্কিটে খালি ওই একটা ভ্যালুই আমাদের দরকার, ঠিক আছে? ইনিশিয়াল সার্কিটে ওই একটা ভ্যালুই আমাদের দরকার নাই। সো দ্যাট ইজ ওয়াই হচ্ছে আমরা ফাইনাল সার্কিটেই বেশি পড়ে থাকবো। এখানেই আমাদের ভিওসি আইএসসি বা ধরেন আমাদের আর থেভেনিন বের করার কাহিনী করতে হবে, ঠিক আছে? জাস্ট একটা ভ্যালু আর কিচ্ছু না, ঠিক আছে? সো লেটস গেট ব্যাক। যেখানে ছিলাম, আমাদের এই সার্কিটে অ্যাকচুয়ালি হচ্ছে শর্ট সার্কিট 0, আমাদের অ্যাকচুয়াল ভোল্টেজ, ওপেন সার্কিট ভোল্টেজও 0 আসবে, অথবা আপনারা যেটা বলতে পারেন যে আমাদের এখানে বেসিক্যালি সোজা কথা সার্কিট লাগবে, টেস্ট সোর্স লাগবে, ঠিক আছে? তো আমি এখানে একটা ছোট কথা বলে আসলাম, যেটা হচ্ছে দেখেন এটা অনেক সহজে কাজে, যেটা 0 ভোল্ট ভোল্টেজ সোর্স যে শর্ট সার্কিটের ইকুইভ্যালেন্ট, এটা কি আপনাদের মনে আছে?
জি স্যার।
যদি মনে থাকে, এই প্রবলেমটা খুবই সোজা, কারণ দেখেন এই যে 0 ভোল্ট ভোল্টেজ সোর্সটা আপনারা একটা শর্ট সার্কিট বানায় দেন। শর্ট সার্কিটের আপনার এই জিনিসটা মানে ডান সাইডের সার্কিটটা যদি থাকে, ওখানে কারেন্ট বের করতে হয়, আপনি এগেইন দেখবেন যে এটা সিম্পলিফাইড সার্কিটটা আমি আঁকে ফেলি, তাইলে বের হবে। এখানে কি ছিল? 20 ভোল্ট 8 ওহম, আমি আকাশে সমস্যা নেই, আমি লেখটা মোটামুটি করতেছি। এখানে আপনাদের ইন্ডাক্টরটা ছিল, তো এখানেই আমার ওই কারেন্ট সোর্সটা বসাইতে হবে। কারেন্ট সোর্সের ভ্যালু জানি কত হবে?
স্যার 1 অ্যাম্পিয়ার।
1 অ্যাম্পিয়ার। কারেন্ট সোর্সের ডিরেকশন কি এই দিকে দিব নাকি এই দিকে দিব? এই কোশ্চেনটা আপনাদের কখনো করা হয় না?
স্যার এটা আমরা করতেছি
স্যার লেফট সাইডে,
কারণ স্যার এখানে স্যার প্লাস মাইনাস দাও নাই ভোল্টেজের।
অ্যাকচুয়ালি আসলে কোনো ম্যাটার করে না, ঠিক আছে? আপনি যদি এই সাইডে দেন তখন আপনার প্লাস মাইনাস হচ্ছে মানে মানে সবসময় আপনি যেটাই নেন না কেন আপনার তীরের মাথায় যেন প্লাস থাকে, ঠিক আছে? আপনি ডানে প্লাস থাকবে, ঠিক আছে? আপনি যদি বামে নেন, বামে নিলে বামে প্লাস থাকবে, ঠিক আছে? তো এটার উপরে আপনি একই রেজাল্ট পাবেন, ঠিক আছে? তো ওই যে যেটা বলছিলাম যে দুইটা যদি ম্যাচ করে তাহলে কোনো প্রবলেম না। সো লেটস ডু ইট দিস ওয়ে। আমাদের মোস্ট অফ দ্য কারেন্ট আসলে এই সাইডে ছিল, ডাজন্ট ম্যাটার, একই রেজাল্টই পাবে। আচ্ছা, তো এখন আমরা এইখানে গ্রাউন্ড দিলাম, এখানে 1 অ্যাম্পিয়ার দিলাম। So we are trying to find the node voltage of this node. Let's call it V1. এটা তো আমি হয়তো সার্কিটটা একটু ছোট করে আঁকা উচিত ছিল। তো এখানে গ্রাউন্ড থাকলে আমাদের এখানে কি কি নোড আছে আমি দেখি, মাত্র 2-3টা নোডই আছে। এখানে দেখতে পাচ্ছি আমাদের 20 ভোল্ট আছে, বাট অ্যাকচুয়ালি আসলে কিছুই ম্যাটার করবে না। আমাদের V1 এর ইকুয়েশন লিখলে আমরা দেখবো যে ইজিলি থেকে ভ্যালু বের হয়ে যাচ্ছে, ঠিক আছে? এখানে V1 নোড 1 এর থেকে কোন কোন রেজিস্টার কানেক্টেড আছে? 2 ওহম। তো 1/2 2 ওহমের উল্টা সাইডে কোন ভোল্টেজ আছে? 0 ভোল্ট আছে, তো 0/2, তো এটা ম্যাটার করে না। আর 0/2 আর লিখলাম না, যাই হোক। আর আপনার 1 অ্যাম্পিয়ার কারেন্ট আছে, এতক্ষণ আমাদের ইকুয়েশনটা আসলো, যাই হোক। So 1 ampere current আছে, so যেহেতু 1 ampere current node 1 আছে, so whatever the value of your current is -1, okay, so equals to 0. জায়গা নাই আমার, নিচে লিখছি। So V1 এর ভ্যালু কত হবে ইকুয়েশন থেকে? সিম্পল ইকুয়েশন
স্যার 2।
ঠিক আছে, এটা আসলে আপনারা এত প্যারা না নিয়ে আপনি যদি ইয়া দিয়ে দেখতেন যে এই 1 ampere কারেন্টটাই তো আসলে এই 2 ওহম রেজিস্টর দিয়ে যাবে, অতএব ওহমস ল ইউজ করলে আপনি V1 = 2 পাইতেন, ঠিক আছে? তো যাই হোক, যেটাই হোক, যেভাবে করেন আপনার রেজাল্ট একই থাকবে, আপনি যদি প্রসিডিওর ফলো করেন। আচ্ছা, তাহলে বলেন তো আপনাদের VT এর ভ্যালু কত ভোল্টেজ? VT এর ভ্যালু তার মানে টেস্ট ভোল্টেজটা কত হবে?
0।
0?
স্যার 2।
মনে আছে ভিটা কি? আপনারা ভুলে যাচ্ছেন ভিটিটা কি? এটা হচ্ছে এই যে 1 অ্যাম্পিয়ার কারেন্ট সোর্সটা বসাইছেন সেইটার আছে যেই ভোল্টেজ, ওটাই টেস্ট ভোল্টেজ। আর এই যে কারেন্ট 1 অ্যাম্পিয়ার কারেন্ট, এটাই 1 অ্যাম্পিয়ার, মানে ওইটাই আই টেস্ট, ঠিক আছে? টেস্ট মানে আপনি যেটা মাত্র বসাইলেন, যেটা দিয়ে টেস্ট করতেন, ওইটাই তো আসলে আপনার টেস্ট সোর্স। ওইটারই কারেন্ট টেস্ট কারেন্ট, ওইটারই ভোল্টেজ টেস্ট ভোল্টেজ। বুঝতে পারছেন? তাহলে এখন বলেন টেস্ট ভোল্টেজ ভ্যালু কত হবে?
স্যার 2 হবে।
2 হবে, বিকজ পজিটিভ টার্মিনালের ভোল্টেজ হচ্ছে 2, নেগেটিভ টার্মিনালের ভোল্টেজ হচ্ছে ডাইরেক্টলি কানেক্টেড টু গ্রাউন্ড, সো 2 - 0 which is basically 2 ভোল্ট। তাহলে RThevenin এর ভ্যালুটা কত হবে? 0/0 হবে না, হবে হচ্ছে কত?
স্যার 2/1।
2/1, 2 ভোল্ট ডিভাইড বাই 1 অ্যাম্পিয়ার which is 2 ohms, ঠিক আছে? সো এখান থেকে আবার একই প্রসিডিওর, যে আপনি সেই RThevenin এর ভ্যালু পেয়েছেন, তো আপনার টাউ এর ভ্যালু হচ্ছে L/R, সেই L এর ভ্যালু যে কত ছিল তত বেশি, তো যেটাই হোক, মনে হয় 0.5 ছিল, তো 0.5 ডিভাইডেড বাই 2, কারণ আপনাদের 2 ওহম হচ্ছে RThevenin, এটার ইউনিট হচ্ছে সেকেন্ড, কারণ ওই যে বললাম টাইম কনস্ট্যান্ট, তো 0.5 কে 2 দিয়ে ভাগ করলে 0.25 সেকেন্ডস পাবেন। ইকুয়েশনটা লিখবেন, তারপরে তো হচ্ছে যে বললামই যে কিভাবে আপনাদের ভোল্টেজটা বের করবেন। আপনাদের 2 ওহম রেজিস্টরের ভোল্টেজটা বের করতে বলছিল, স্ক্রল করলে তো সময় লাগবে ওখানে লোড হইতে। তারপরেও দেখা যাক। আচ্ছা, দেখি এখনো আসে নাই। আরে ভাই, এত ভেজাল কেন?
স্যার আপনি কি স্যার
হ্যাঁ,
ঢাকার বাইরে?
আমি ঢাকার বাইরে না, আমি ঢাকার বাসাতেই আছি। বাট আমি হচ্ছে নেট দিয়েই চালাই, নর্মালি ইয়া দিয়ে চালাই, কিন্তু হটস্পট দিয়ে চালান তো একটু গ্যাঞ্জাম হচ্ছে আর কি। আমি আসলে সুইচটা মানে অন্য সিমে সুইচ করলে মনে হয় ভালো হতো কিনা জানি না। যাই হোক, হোয়াটএভার, যদি আই এর ভ্যালু পান তাহলে আসলে আপনার ভি এর ভ্যালু পেয়ে যাবেন। আপনাদেরকে মেইনলি ভি বের করতে বলছিল। সো ইন্ডাক্টর থাকে সবসময়ই আপনার মেইন কথা কারেন্ট বের করবেন, এবং কারেন্ট বের করার জন্য আপনাকে মানে যেটা করতে হবে, প্রথমে একটা প্রবলেমকে দুইটা প্রবলেম বানাইতে হবে সুইচ করে। ঠিক আছে, সুইচের কারণে আপনার দুইটা প্রবলেম তৈরি হবে, একটা ইনিশিয়াল সিচুয়েশন, একটা ফাইনাল সিচুয়েশন। এরপরে জাস্ট মনে রাখবেন আপনি থেভনিন করতেছেন, যা করবেন শর্ট সার্কিট, ওপেন সার্কিট, ভোল্টেজ টেস্ট, ইনভার্টার ক্যাপাসিটর জায়গায় করবেন। ঠিক আছে, তো আমি আপনাদেরকে অ্যাডভাইস করব আপনারা লিটারাল এরকম ভাবে লিখেন যে হ্যাঁ ইনভার্টারকে আমরা এসি বের করবো, থেভনিন বের করবো, মানে আপনারা যে কাজটা করতে চাচ্ছেন সেই স্কিমটা দ্বারা করান। I think that should be much useful to you than you think. ঠিক আছে
স্যার আমরা যে আই এরটা পেলাম উপরে, ওইটা তো একটা হচ্ছে মানে ইকুয়েশনের মতো ফর্মেটে পেলাম, নট ইকুয়েশন বেসিক্যালি। অ্যান্সার আসে হচ্ছে আই এর 48 ইন্টু e⁻t/0.05। ওইটার সাথে যে সিম্পলি রোধটা গুণ করে দিব, এটাই তো মানে ওই ওই
Yeah.
আমাদের রোধের ভিতরে যেটা ভোল্টেজ বের করতে চাচ্ছি।
মাত্র হ্যাঁ ওটাই করতে হবে, আর কিছুই না। মাত্র
আচ্ছা
একটা জিনিস নেটওয়ার্কের প্রবলেম হচ্ছে।
Sir, how many questions will be there in final?
Sure, 3 or 4. Okay, so basically your exam duration will be probably 2 hours. Okay, so the time duration of your exam, but I cannot say what how many questions will be there. Okay, 3 or 4 depends on the difficulty. Okay, but the question will be like 2 hours long. Okay, so your exam will probably be 2 hours long, and the question will be set like that. I think it's better if you have 4 questions, but it will depend on the difficulty. Okay, if you have 4 questions, means that you have easier problems. But if you have 3 questions, that means you have relatively difficult problems or time-consuming problems. Okay, so you need more time. Usually, you will have 30 minutes to solve each problems. And again, the most time-wasting thing you can do is basically get your which your calculator can do in a second. Okay, so please don't waste your time on that. Okay, so now let's move on from transient analysis. Is there any other question on transient analysis?
No sir, thank you.
Okay, so we have AC analysis right now. So for AC analysis, there is 2 advice I want to give you. First of all, try the AC analysis at the very end of your exam. Okay, so AC analysis is quite time consuming because you are dealing with complex numbers and you'll have to solve these equations by hand. So we will try to give the problems is that you can solve those equations by hand. Okay, but nonetheless, you have to do that. You have to, and because calculator you have complex mode, and then you have equation solving mode, but you cannot write complex numbers in your equation solving. Okay, you have to. So let's try to solve a problem. So let me take a problem from your book. And again, for practicing, Sadiq's book is good enough. Okay. And in fact, your quiz questions were from Sadiq's book, just a bit modified. AC power analysis, instantaneous proposition. Okay. So let's see if I have. Okay. So we have a voltage source here. Let me write it, 50-volt voltage source. I think the lag might be getting a bit better. I didn't know that I was running both of the devices on one mobile data connection. Sorry for it. Okay, so for this problem, what you have to do is find V naught. Okay, sinusoids, so the result will be sinusoids. But we will solve this problem in complex mode. Okay, so we're going to solve this problem by hand completely because this is what you have to do. Okay, AC analysis problem. You have to first convert to cos. Everything should be into cos. Cos function. There should be no sin function. Okay, this is first job. And how to do that? If you have sine theta is equals to cos theta minus 90 degrees. Just remember that. Okay. Next, after you have converted all of them into cos something, remember you have to convert them to
complex
numbers. So how can you convert complex numbers? Well, if you have sine and cosine function, for example, if you have so you should have only cosine function of the after the first step. You should just remove this part. If you remove that part, that is how you find your complex number, A angle theta. So if you guys remember, A angle theta is one way to write complex number. Most of you are familiar with A plus BI format, but there is another way to write it, write complex numbers, that is R angle theta. Okay, and your calculator supports this mode as well. So before AC analysis, please make sure that your calculator is in polar mode. Okay. How can you make sure that? Well, I don't have exact SEO copy, right? So I don't think this will work. Well, you have in degree, so that should be your first. Menu will not be in this format, but still, there should be one one main option where you can switch the angle unit to degree instead of radian. So make sure this is in degree. Okay, and the output for the complex number, there should be another settings or mode, complex result. How do you want to see the results of the complex numbers? Okay, so that should be, I don't know, is this in format? That should be in R angle theta mode. So this is not like your Casio calculator, so I don't think this is worth exploring. So whatever, you should have this type of scenario where you have a cosine function. For example, you have 4 cos 10t, right? So if this is your conversion factor, this is a cos 10t, then you can write this. So what I'm trying to write is 4 cosine. You can write this as 10t plus 0 degree, right? If you don't have anything, you at least have 0, right? So you just remove this cos 10t part, and this should become 4 angle 0 degree. Okay. This is how you convert sines and cosines into complex numbers. However, there is a huge caution. Okay, there is a huge caution here. There is a huge caution here. There should be only are you guys connected? Yeah. Okay. So there can be only one omega for a circuit. Okay. No more, no less. Okay. For example, in this circuit, if we convert this sine to cosine, it will be something like cos 5t plus something, or cos 5t minus 90 degree. So you have cos 5t on one end. So let me write it. 50 cos 50 minus 90 degree. After the first we should have 50 cos 5t minus 90 degree. Okay. So this is after your first step. Now you have cos 5t on one end and cos 10t on at the other end. If you have omegas, so you have different omegas. What is the value of omega for this circuit? Is it 5 or 10? If you have different omegas, like, you will need superposition theorem. Okay. So if you have sines and cosines, the best way is remove the cos omega t part and replace it with an angle sign, and that is your complex number. Okay, so this is your step 2, and let's finish the for the inductors. How can you convert to complex numbers for inductors, capacitors, and resistors? So if you have a resistor, say 10 ohm resistor, well, just write 10 as your impedance. Okay, so if the value of R is 10 ohms, the impedance is basically R. Okay, or if you want to write it as a complex number, you can write it as R angle 0 degree, which does absolutely nothing. Okay, basically, if you have 10 ohm here, this is 10 angle 0 degree. If you have an inductor, say for example 10 ohm, the formula is omega L 90 degree. Okay, what's the value of omega? Well, that is the value you get from the second step. Okay, so you will have 1 omega. So if your omega is 5 times L times 90 degree, that is 90 degree ohms. The unit of impedance is ohm. Z is impedance, the complex resistance. And capacitor, if you have a capacitor, say 10 farads, and your omega is 5 again, say, that means your Z equation for capacitor is 1 by omega C angle minus 90 degree. So you can write the 1 angle minus 90 degree like this as well, and divided by omega C. Okay, so 1 angle minus 90 degree divided by omega is 5, and your C is 10. That means 1 by 50, which is 0.02, right? Minus angle 90 degree. So this is how you convert complex. Okay. So if you have a complex number, this is how you can. So if you have voltage source and current sources, how you convert it from cosine, sine cosine to angle degree. But if you have RLC, that is resistance, inductors, or capacitors, you basically use these formulas. Okay. Okay. Now, let's try to solve this problem from top to bottom. Okay, I'm going to solve this problem, and you will probably have similar type of problems. So pay attention how you will solve this problem. Okay, so the first step is to see, yes, do you have different omega here? You have 10 here and you have 5 here. So yes, you need superposition theorem. So that means again, you have split your problem into 2 different problems. Okay, so if we are using superposition theorem, this can be written as 2 different summation of 2 different circuits. Okay, this can be written as the sum of 2 different circuits where one of the sources are active in each case. Okay, for example, in the first circuit, say for example, the voltage source is active, and this we kill this current source. How do we kill a current source?
By open circuit.
Yeah, we open that current source. And for the other circuit, say the current source is active and we kill the voltage source. How do we kill a voltage source?
By short
circuit.
Yeah, we make it short. So this is your first step if you have different omegas. And if you don't have different omegas, well, you are lucky because this is an easier problem. Okay. And let's name the first one V output prime and other one V output prime. That means our V output should be V output prime plus V output double. Okay. So you have to individually solve these 2 problems. So let's try to solve this one first. Oh, sorry. Sure. Okay, so we are trying to solve the first problem. I don't know if it's visible. Let me enlarge it. So first step, we have to make it cosine. And the way we do this is basically angle minus 90 degree. Right? Just to show you another example, say the value was 4 sine pi t plus 30 degree. Then what should be the cos value? Cos 5t What should I write here?
-60.
-60, yeah. This is because you have +30 degree, -90 degree, which is basically -60 degree. So if you have an angle, you have to consider that as well. Okay, so here we don't have anything else. So we just have cos 5t here. So the way to convert it is very easy, 50 angle -90 degree. And what's the value of omega? 5. Hence, well, our resistance is 8 ohm. I'm not going to change that. This value, so our capacitance. So let's give them a name. So this is Z1, this is Z2, and this is Z. This should be our Z3. Okay. This value of Z2 should be 1 angle -90 degree divided by omega c. So 1 angle -90 degree, the value of omega is 5 and the value of c is 0.2. That gives us, so which is 1 angle -90 degree ohms. The unit capacitance is, so the unit of impedance is ohms. Okay. And for Z3, the formula is omega L angle 90 degree. The omega's value is 5, L's value is 1 Henry. So we have 5 times 1 angle 90 degree. So 5 angle 90 degree ohms. This is your Z3. Okay. So I'm going to redraw this circuit just to make it more easy to visualize using our complex circuits. Okay. So this is the angle was 50 angles 90 degree. We had a resistor here, which is 8 angle 0 degree ohms. You can write it like that. We had a capacitor here, which is 1 angle -90 degree here. We had an inductor here, which is 5 angle 90 degree here. Okay. Yes, and the other part is open, so we don't need to worry about that. But what we need to worry about is our voltage, what we wanted to find out. To find out V output prime. So yes, so we have to find the voltage across our capacitor. So you can do node analysis, mesh analysis, etc., whatever. Or you can also do voltage divider rules, current rules. Okay, however I want to do it. Let me do it using node analysis, because this voltage is 50 angles -90 degree voltage. And this is, let's call it V1. Okay. Or maybe give this a value, doesn't matter. So we try to write equation here. V1 times 1 by, so remember this our Z1, our Z2, and this is our Z3. So if you're trying to solve the problem, this is basically like our resistance, impedance is basically resistance. At 1 Z2 plus 1 Z3. All of them are connected to node 1. Then you have voltage 50 angle -90 degree on 1 divided by Z1. Okay. And the other end of Z2 and Z3 are basically 0. So I'm not going to write them. Okay, equals to 0. So from here, you can see that the value of one is quite simple to figure out. If you can figure out the values of Z1, Z2, Z3. So I'm going to show you how you are going to put in these values, complex numbers here. Okay, I'm going to complete the problem by hand and then you are free to go. So let's enter complex mode. Otherwise, you won't be able to write complex numbers. Okay, so let's calculate the value of 1 by Z1, 1 by 2, and 1 by Z3. So I'm going to write 1 divided by Z1. What's the value of Z1? Z1 was 8 angle 0 degree. 8 angle, angle 0 degree means just 8. So it's fine if you write it like this, or if you want, you can write 8 angle 0 as well. Doesn't actually matter. Plus 1 over Z2. What is Z2? Z2 is 1 angle minus 90 degree. 1 angle minus 90. Okay. And finally, we have 1 angle Z3. 1 angle, sorry, or 1 divided by, doesn't, 1 divided by 5 angle 90 degree. So you get some value here. I'm going to see the result here. So the polar form is quite difficult to see, but it is 0.8 angle 81 degree. V1 times 0.81 angle 81 degree. I think this was the value. And on the other hand, we have 50 angle minus 90 divided, or you can use the fractional format. I prefer this. Z1. The value of Z1 is 8. So you have 6.25 angle minus 90 degree. So if you're trying to find the value of V1, you should divide by 0.81 angle 81 degree. So I can do that. I can divide the answer by 0.81 angle 81 degree. Okay, so that gives us in polar format 7.71 angle minus 171 degree. You don't need to write the precise value. Okay, just write it up to 2 decimal points. That's fine. Okay, so this V1 is your V not prime. Okay, this is your VO prime. Okay, so if you remember the circuit, this VO prime is equals to V1 minus 0, so which is basically V1. Okay, so this value is your V naught prime. But the problem here is this is in complex number, but the value should be written into cosine format. And the way is also quite easy to do that. 7.71 cos 5t minus 171 degree, because this is basically the opposite of how you convert it to complex. You remove the cos 5t part. Now you are inserting this cos 5t part. This is your V naught prime. Okay, and remember, this is just one part of the problem. You also have to find V output prime for this circuit. Here, oftentimes, students forget to find the Zs again. Okay, the Zs will change. The impedances will change. Sorry. Yeah, the impedances will change. Why is that?
কারণ ওমেগার ভ্যালু চেঞ্জ হচ্ছে এই জন্য। কারণ ওমেগার ভ্যালুটা চেঞ্জ হচ্ছে এই জন্য। প্রিভিয়াসলি ওমেগা 5 ছিল, এবার 10 হবে।
Yes, since your value of omega is changing, because your omega is 10 here, cos 10t, it's already in cos. So this should be 4 angle 0 degree, except for the fact that you have to remember the value of omega is 10. That means your Z1 is 8, that's fine, but Z2, which was 1 angle minus 90 degree divided by omega c, your omega has changed 10 times 0.2, and you have 1 angle minus 90 degree. You can do these calculations on your calculator, and basically you get 0.5 minus 90 degree, right? So your Z2 have changed from previous value. It was 1 angle minus 90 before. So you have, remember, you have to recalculate your Zs. For the factor, you also have to recalculate that because you have omega here. 10 times the value of inductance is 1 angle 90 degree, which gives you 10 angle 90 degree. Right. So once you have done that, then it's very simple. You have to do DC analysis type stuff. So this is Z1. I'm just going to write the values. Also, if you are mixing them up, just use this box. I like them because that basically makes you forget that this was ever an inductor or capacitor. So now again, you have to find V output double prime, which you can do in multitudes of ways. But I think the best way would be to just use current divider rule, because you have Z1, Z2, Z3 all in parallel. Can you see that all of them are in parallel? All of them share the
Yes,
same
sir.
two nodes, this node and this node. There are only two nodes in this circuit. So if you are doing current divider rules, you have some current and you have multitudes of resistors or impedances, doesn't matter. And if you're trying to find some current, for example, if we are trying to find I2, I should mention there is a controversial equation, okay, kind of, there is controversy about math, but you know, the thing is, if usually students learn a special case, but please remember that that is only for two resistors. I'm going to show you the general form, okay? So remember how in voltage divider rules, if we had some voltage like 30 volts time all the resistors like 3 plus 6, and we want to the voltage across one resistor, say the 3 ohm resistor, this is how we write it. For current divider rule, for example, we have 4 angle 0 degrees here. The value of I2 will be to divide this 4 angle 0 degree, this 4 amperes into all these resistors. That is Z1, Z2, Z3. But the only different part is that you have, these are all inverted, 1 by Z1 plus 1 by Z, just like in parallel connection, okay? All of the resistors or inductors will be inverted. This is actually true for even resistors, okay? 1 by R1, 1 by R2, 1 by R3, okay?
So voltage
Remember that
divider rules are ক্ষেত্রেও শুধু current divider?
Yes, for current divider rules, the general formula is actually the inverse of resistor, okay? So please remember that. Because, okay, let me just sidetrack a bit. If you have a current source, I think you have learned that, say, for example, we want to figure out I2. The current is, say, I. What we write is I2 equals to I times all resistors added up, and whatever current you are trying to find, write the resistor, the opposite resistor, R1, right? This is the formula you have learned. The thing is, if you have 3 resistors, what is the opposite resistor? Is it R1 or is it R3? So that is not actually a general formula. The general formula is this one. Okay, if you have 3 resistors like this, just take the inverse, add the inverse of them. Okay, just take the inverse of the resistors instead of taking resistors, and it works perfectly okay. Okay, so keep in mind, this is the actual current divider rule. So So we have 4 angles 0 degree times 1 by, so z's. So I'm going to change them back to z's. So the value of Z1, Z2, and Z3. So why not I just write the values directly in calculator? So 4 angle 0 degree. I'm not going to write the angle 0 degree. So Z1, the value of Z1 was 8. I'm just going to write inverse to denote that 1 by Z1. Okay. So sorry, I needed Z2 inverse, right? I needed Z2 inverse. The value of Z2 was so 0.5 angle minus 90 degree, and take the inverse of that. And on the bottom, we have inverse of all the impedances. So the result is your current I2. So if you put in all these values, the result we get is 4.2 angle 3.76 degree. Okay, or 3.8 degree, whatever. You don't need to write up to 2 terms, 2 decimal points in the degrees term. Now, if you're trying to find the V out prime, basically multiply that current by the Z, right? Z2 times 2, I2 times Z2, and we already know the value of Z2. All we need to find is the value of V out by multiplying it by Z2. And the value of Z2 is again 0.5 angle minus 90 degree. I'm sorry if I am boring you, but this is the procedure to solve this problem, okay? And the value is 2.1 angle minus 86 degree. So if again, you have to convert it to cos, which is basically 2.1 10t minus 86 degree. Remember, the conversion factor was 10. The omega value of omega was 10 for this problem. Okay, so this is how you get V double prime. And finally, this is your result. V output was V output prime V output double prime. Okay, so the value of V output prime was 7.71 cos 5t. I'm just going to copy this. Plus the value of our V double prime. Okay, so this is complete. I can just write them one line, but if I could, I could. So this is your final result. So you'll have to solve a problem similar to this, I think. Okay, I don't exactly know because the questions has not set yet. So there is no way I can tell you what's in the exam, but my intuition says that you will have some problem similar to this. You'll have 2 or 3 mesh, but easily solvable by probably by voltage divider and current divider rules, or you can easily solve them by node or mesh as well. Okay, for example, if you had used node analysis here, it was also easily solvable. You only have 2 nodes and one of them would be ground, and you have to write the equation for the other one. Okay, so this is how you would do AC analysis. And the at most you can be asked to do RMS. I don't think you'll be asked to do RMS voltage or anything. Okay, so you're fine. All you have to do is up to this point.
স্যার এরকম সুপারপজিশনের জন্য যদি আরএমএস আসে তাহলে তো আমাদের এখানে এর ভ্যালু তো দুইটা 7.71 আর 2.1 এখানে এ টাইমস হবে না
if you have this kind of thing, do you remember what the RMS stands for? Root, mean, squared. Yeah. So what happens is that if you only had this one, 7.71 by root 2 would be your RMS. If you only had this one, 2.1 divided by root 2 would be your RMS. But if you have both them, you have to take the root mean squared value. That means 7.71 by root 2, you have to square them first. Then you have to take the mean. You have two values here, so you divide it by 2. Then you take root of them. Okay, but I don't think we'll be asked to find the value of RMS value if you have a superposition situation. Okay. So I think you can just ignore this part. So if you have superposition, I think this, and I think you will likely be solving a superposition problem. Okay, so your problem will probably be something similar to this. The circuit will of course be different, but it will be easily solvable, and you'll never have more than 2 voltage sources. Okay, and you'll never have more than 2 sources. Or 2 omegas, I think I should say. You'll never have more than 2 omegas, so that you don't have to do more than 2 super. I think this AC part is a bit lengthy and kind of boring, but this will be one of the questions in your final exam. So yeah, you have to get through them. So yeah, that is it for today's consultation. Sorry, I took almost like 2.5 hours. So my final advice would be to focus on node and mesh particularly, because if you make mistakes there, I don't think you will have to worry about transient and AC analysis. So after you have foundations that yes, you know how to do node and mesh, move on to transient, Thevenin, AC analysis. And during the exam, try to solve the AC analysis problem at the very last. Also, try to write the equations first. Keep blank space where you solve those equations and etc. Okay, so at least write the equations for each questions, because if you can write the equation correctly, you get more smart. Okay, so that's it. Do you have any other questions?
No, sir. Thank you so
No,
much.
sir. Bye, sir.
It was a very helpful session. Thank you.
Okay, so I can stop the recording here. And if you don't have any other questions,